All right, let's talk about something that's literally holding our world together, but you probably never see it: the seamless steel pipe. Today, we're going to go on a journey from just a glowing block of metal to the super strong backbone of, well, almost everything. So yeah, let's get right into it.
I mean, just look around you. Chances are one of these is closer than you think. They're like the hidden arteries and skeletons of our entire civilization. They carry our water, our gas, they hold up our skyscrapers, and they do it all silently, under enormous pressure, day in and day out.
And that's the million-dollar question, right? It's one thing to make a hollow tube, but it's a totally different ballgame to give that tube the insane strength it needs to handle these extreme jobs. The secret, as we're about to find out, is all forged in fire.
Okay, so our story starts right where you'd expect, in the intense heat of a factory floor. This is where a solid chunk of steel begins its pretty incredible transformation.
Now, the most important word here is seamless. See, a lot of pipes are made by just rolling up a sheet of metal and welding the edge shut, but not these. A seamless pipe starts as one solid piece of steel. No seam means no built-in weak point, and that uniform strength is exactly why they're so critical for anything high pressure.
The whole process is this incredible dance of heat and brute force. First, you take a solid steel billet and heat it up until it's literally glowing red hot. Then comes the wildest part, the piercing. A massive tool basically punches a hole right through the center. From there, a series of rollers stretch and shape that hollow shell to the exact size needed before it finally gets to cool down.
And check this out. This is that exact moment of piercing I was talking about. Look at the sheer energy there. A solid block of steel becomes a hollow tube in, like, the blink of an eye. This is where its basic shape is born, all thanks to some unbelievable heat and pressure. Just to give you an idea of the massive scale we're talking about, a single factory can crank out 8,000 metric tons of this stuff every single month. To put that in perspective, that's like the weight of more than 40 jumbo jets. It's a staggering amount of steel, and it just shows you how much we rely on these things.
But here's the twist. The pipe's journey is far from over, because fresh off the line, it has a serious problem. A kind of hidden weakness that makes it totally unfit for the job it was created to do.
So is it ready to go? The answer is a big fat no. It might look like a finished pipe, but on the inside, its molecular structure is a complete mess. It's full of stress, it's inconsistent, and it could be super brittle. If you put this thing to work right now, you'd be asking for a catastrophic failure.
And here's a breakdown of those invisible flaws. That whole violent process of piercing and rolling creates a ton of internal stress. The little crystalline grains inside the metal are all jumbled and uneven. And, depending on how it cooled, the pipe might be too hard and crack like glass, or maybe too soft to even hold pressure.
And this is where the real magic happens. To get rid of those flaws, the steel has to go back into the fire. Through a few very precise heat treatments, we're not just fixing the problems, we're actually unlocking the steel's hidden superpowers.
So superpower number one is called annealing. You can basically think of it as a day at the spa for steel. It's all about chilling out and getting rid of stress.
The process itself sounds pretty simple, right? You heat the pipe up, let it soak at that temperature for a bit, and then, and this is the absolute key, you cool it down incredibly slowly. This super gentle cool down lets the steel's internal grain structure just relax and rearrange itself into a much more stable, uniform pattern.
And what do you get at the end? The steel is softer, it's not brittle anymore, and it's way easier to cut or machine. But most importantly, all that dangerous internal stress from when it was made, gone. The pipe is now stable, it's predictable, it's ready for the next step.
Okay, but what if you don't want soft and workable? What if you need something with wicked strength and toughness? Well, for that you need a much more aggressive superpower: quenching and tempering.
This is basically a two-part shock treatment. First, you heat the steel way up, and then you plunge it into water or oil to cool it down super fast. That's the quench. This shock freezes the steel's atoms into this really tight, stressed-out structure that's incredibly hard. The problem is, it's also brittle. So then you do step two. You gently reheat it or temper it. That lets the structure relax just a tiny bit, trading a little hardness for a massive boost in toughness.
What you end up with is pretty much the holy grail for engineers. It's a material that is unbelievably strong and hard, but also tough enough that it won't shatter on impact. It's the perfect balance, custom-made for the absolute toughest jobs out there.
Now our third superpower is for a very special material: stainless steel.
To unlock its most famous ability, not rusting, we need a process called solution treatment. For this one, you heat the stainless steel up to a really high temperature, and the whole goal is to get all the different ingredients like chromium and nickel to dissolve completely and spread out evenly through the steel, kind of like dissolving sugar in hot water. Then you cool it down fast to lock that perfect mix in place.
And getting that perfectly even homogeneous structure is what it's all about. This process is the exact thing that gives stainless steel its legendary power to resist rust and corrosion. Without this step, it just wouldn't be stainless steel.
So we've forged a pipe, and we've unlocked its superpowers. Now, let's bring it all home and see how this stuff goes from the factory floor to the very foundations of our world.
And here's the payoff. A pipe that's been through solution treatment isn't just a pipe anymore. It's a highly engineered piece of equipment, ready to go into a chemical plant or a marine environment and just shrug off the elements for decades.
And the places you'll find them are just endless. Depending on which superpower it was given, a seamless pipe could end up miles underground in an oil pipeline, or inside a super high-pressure boiler at a power plant, or even forming the frame of a giant offshore oil rig. Each treatment perfectly tailors the pipe for its specific and very critical job. So, you start with a simple block of steel, you put it through incredible heat and pressure, and you end up with a material that has actual superpowers, tailored to meet our biggest challenges. It really makes you wonder, right? With a foundation this strong, what are we going to build next?